Hello everyone. Let us solve the following. Length of the shadow of a 15-meter high pole is 15 root 3 meters at 8 o'clock in the morning. Then, what is the angle of elevation of the sun rays with the ground at that time? Okay. So, let us solve the following by using trigonometric ratios. Okay. Yes. So here we can model the situation as a right angle triangle formed by the pole, its shadow and the sun rays. Okay, due to sun rays, there is a shadow of the pole. We are modeling the situation as a right angle triangle. What is given actually height of the pole is 15 meters. Okay, and the length of the shadow is 15 root 3 meters. Let us consider the angle of elevation of the sun is theta. Okay, height of the pole and the length of the shadow they are given in the problem only, right? So when we model this diagram, if you observe, this is the pole which is nothing but 15 meters length. Okay, and this is the angle of elevation that we are going to find it out, and the length of the shadow is this one. Okay, right? So here we are creating the right angle triangle, right? Yes, as the pole is straight on the ground. Okay, so the problem provides the height of the pole h and the length of the shadow s. Okay, here both are given. Height of the pole is 15 meters and the length of the shadow is 15 root 3 meters. Okay, so the relationship between the pole, its shadow, and the sun's angle of elevation forms a right angle triangle. That's what we have already discussed. Okay, just this all the when we model all these 3 points, when we get a right angle triangle here. Okay, where theta is the angle of elevation that we are going to calculate, right? Now, what is given? Height of the pole h is 15 meters, length of the shadow is 15 root 3 meters. Okay, so the angle of elevation theta is related by the tangent function. So if you observe, this is the angle of elevation. When we take this angle into consideration, it becomes the opposite side, and when we consider the same angle, it becomes the adjacent side. When adjacent side and opposite side are known to us, we can use tan theta. As we know, tangent function, sine function, cosine function related to the given values, we need to take it. Yes or no? So here opposite side is given as well as adjacent side is known. Then definitely we can use tan theta, tangent function. Okay, so in a right angle triangle, what is tan theta? Tan theta is nothing but opposite side by adjacent side. So here we are substituting the given values into the tangent equation. So trigonometric ratio of tangent. Okay, so tan theta is equal to opposite side by adjacent side. Opposite side is nothing but the height of the pole, and adjacent side is nothing but the length of the shadow. Then tan theta is equal to, so we are substituting the values. Height of the pole is 15 meters and length of the shadow is 15 root 3. Okay, so when we substitute, 15 15 gets cancelled. Finally, 1 by root 3 is remaining. Okay, so tan theta is equal to 1 by root 3. Okay, of course, this is the standard trigonometric value. So, where will we get 1 by root 3 as tan theta? The value of angle theta for which the value of tan theta is 1 by root 3 is 30 degrees. When the angle is 30 degrees, definitely we will get tan theta is 1 by root 3. That means tan 30 is 1 by root 3. So theta is nothing but 30 degrees. Okay, so the angle of elevation of the sun rays with the ground at that time is 30 degrees. Okay, so we are able to find theta value by simply substituting the trigonometric ratio tangent. Okay, so tangent is equal to opposite side by adjacent side. So substituting those values, we got tan theta is equal to 1 by root 3. 1 by root 3 is nothing but tan 30. So theta value is 30 degrees only. Okay, I hope you understood the problem. If you understand, please like, share and subscribe.